Welcome everyone to Passive House Accelerator's 7th Global Passive House Happy Hour of 2021 and episode number 48. Thanks for joining us. My dog is joining too. I'm Prudence Ferreira. I'm a senior member of the Carbon Neutral Design Group at PR+A Consulting Engineers, and I lead their Passive House team. And the Accelerator Happy Hour is an inclusive gathering, welcoming everyone. So when
It's
oh man,
just so you know, it's not super loud for us. I mean, we can definitely hear it, but it's not. Yeah,
she's talking up a storm, man. So, all right. So whether you're a dog or a homeowner or a professional in the building industry, a teacher or a student, if you're just curious and learning, or you know a lot and you're still learning, you are in the right place to learn about Passive House and how to reduce greenhouse gas emissions in our built environment. So one of the headlines that I was reading today said this: millions of jobs unlikely to come back even after a pandemic, economists warn. But at the same time, on Monday night at the Retrofit Summit, I heard James Gepner of Retrofit New York say that in order to meet our 2050 zero emissions targets in the US alone, we would need to do 9,406 retrofits per day, which equates to 783 retrofits per hour. So expand that to the rest of the planet, and I'd say this is potentially another silver lining of this whole mess we're in. The high performance design and construction community, man, we've got an incredible opportunity to be part of the solution in terms of helping create new jobs and helping our elected leaders understand where funding is needed for workforce development and where the gaps in knowledge and skill are. And additionally, with the shifting of the economy, there's now going to be even more low-income families who need healthy, affordable places to live. So I'd like to invite everyone to unmute yourselves and help me open up our show tonight with this toast. All right. The dress rehearsal is over, guys. It's over. It's our time now. So here's to helping shape our new carbon economy and knowledge transfer. Cheers.
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 Long and prosper.
Cheers.
Our time.
All right. So put yourselves back on mute and put on your seatbelt. We are going to journey into the world of Dennis Wedlick tonight and his visionary work with Habitat for Humanity and providing energy security through Passive House. But first, over to Zach for our video clip.
Yeah, thank you. So we have a really cool video tonight. This is a video that is taken from the AIA New York Research Practice Series webinar from January 26th. And that January 26th event was organized by Dennis Wedlick. And Dennis invited me to moderate a panel, a conversation between practitioners about residential passive house practice. And the idea that once you've experienced passive house design and construction, there's no going back. That idea came up a lot in this panel conversation, and the accelerators, Sydney Gladu, put together this highlight reel from the conversation that we want to share with you all. So here we go. Why passive house?
Having gone through all that trouble, would they do it again? Well, the answer is yes and more. Phase one, they met and achieved passive house. They have the insulation factors they needed. They had the air tightness. They figured it out. They know the concepts. They did it 12 times. They now have a phase two where they're going to do it 12 more times. And so they actually decided to take it even further.
It's not just about the projects for us that are going passive house. Like I mentioned, it's sort of a smaller fraction of our total workload, but it influences all of the other work that we do, because now the more experience we have with these air barrier challenges, with more innovative mechanical systems, with electrification, the better we're able to guide other teams towards those similar goals as well.
And it wasn't until we decided to make a commitment in our office to build a passive house that we really tried to figure out, how do we make that jump? How do we fill that gap? How do we make that void where everyone's always cold at that sill plate in their house? How do you fix that? And that kind of was like, well, this makes a lot of sense.
You can actually get some people that way.
Once you peek through the veil, into the passive world, it's hard to go back.
I was like, okay, if we're gonna promote this and we're gonna go for this and we're gonna try to, have new clients buy into Passive House, I think I have to experience it. I have to see how we're gonna build it, and mainly I want to live in it, and so I can express to people what it feels like. And it's still hard to express it until someone walks into a house to really get a sense of the cocoon type feeling that it has, lack of temperature fluctuation, and it's kind of like you're wrapped in a blanket somehow.
Extremely demanding project to execute properly and finish on all levels. How do you feel about Passive House now that the dust has settled? Would you do another one?
Absolutely.
First time I heard about Passive House was from you. And you said there's this thing called Passive House, and I thought, well, Michael's gone off the deep end, and this will probably be the last time I work with him. But fortunately, you kept promoting it, and you kept talking about how it's really cool, and I kept hearing little things here and there, and got invited to a few of the open houses. So much fun to, after being in the business for 30 years, to be learning new stuff, for me, is as good as it gets.
There is a Passive House high energy efficiency world, and there is the other world that is not that. We have been welcomed into that Passive House world. Like he feels like he passed some border or barrier into the Passive House world by being able to talk, by understanding the language. We all have so much to learn every day, but once you get into it and start knowing the terms, you're listening, you're learning, you're part of it.
Passive House, green building, where it's solar, everybody's just assuming that they can't have something. And it's just this really cool thing for us that you can have more. We're giving our clients more. We're saving the environment while they're getting a better building. It's kind of a win-win. It's really nice.
All right, thank you. And thank you, Sydney, for putting that together. And of course, to Dennis for making it happen. So we're going to go into breakout rooms now for 5 minutes. And this gives everybody a chance to do rapid fire introductions. So make sure you get around to everybody in your group. So every week at the Passive House Accelerator website, we publish a Passive House Week in Preview that talks about what's coming up next. And so I just wanted to share some highlights from that. But you just know that you can go to our website at passivehouseaccelerator.com to find all the stuff that I'm going to show you. We just had a great retrofit summit yesterday that we'll have the video for early next week if you're curious. You're here for our happy hour, of course. We also have a really fantastic episode of the Passive House podcast. Dennis also had a great episode with us on the Passive House podcast a few weeks ago. This one is with the happy hour's own Prudence Ferreira. She's the co-host of the happy hour, and she talks about the role of evolutionary algorithms in Passive House and the potential for scaling up. It's really cool stuff about machine learning and all sorts of interesting new kind of potential.
And dancing.
Yeah. What was it? And dancing? Thank you, Matthews. That's you just heard from Matthew Cutler Welsh, who conducted the interview. He's co-host of the Passive House podcast. The reason the podcast exists is Matthew Cutler Welsh. So yes, and dancing, and the choreography of Passive House, I think, is the poetic way that Matthew refers to that interview, the conversation. So there's also every week a bunch of great socials, and so here's a list of them, including the Building Science Fridays that is co-hosted by Mark Willey, who is of Construction Tech Tuesday. So check those out, and always great resources, educational resources from NAPHN and FIAS and Australian Passive House Association and Passive House Canada and all sorts of other great groups. So that is it for my announcements, and I want to hand it off to Prudence, who's going to introduce our esteemed speaker.
Thanks, Zach. So tonight we are honored to have with us Architect Dennis Wedlick. and he is the founder of BarlisWedlick Architects, which was formerly Dennis Wedlick Architect. He's known for his rural custom homes that focus on sustainability, and in the best tradition of knowledge transfer, Dennis actually apprenticed for 12 years under master architect Phillip Johnson before opening his own firm. And in 2011, when he did his first passive house, he started exploring the power of passive house design to mitigate energy poverty in rural communities. And he has carried that forward into future projects. Not only is his architecture helping to create equality that way, but it's beautiful. It's been featured by the Smithsonian National Design Museum, and Habitat for Humanity in Columbia County called him a visionary whose designs concern not only the health and welfare of his clients, but the community at large. He's also the author of 5 books on residential design. The most recent one is called Classic and Modern Signature Styles, which he co-authored with his partner, Alan Barlis. So tonight, Dennis is gonna share with us 3 case studies from the Rural Build Initiative that showcase just how passive house can provide energy security in rural housing. Dennis, thank you so much for your work, and thank you for joining us.
Well, it's a real pleasure to be here. I did ask if I could pre-record my presentation because I am in a very rural area, and any minute of any day the power can go out. So I thank you very much for allowing to do this. I'm sure you're going to enjoy it, and I look forward to talking to you afterwards. I do want to say that I'm super grateful that we had the opportunity to go straight from high-end residential design to affordable housing. And we couldn't have done that without our community here. And this is all about building community and how important that is. So my name is Dennis Wedlick. I am founding principal of BarlisWedlick Architects. We have offices in Hudson, New York, and in New York City. What we're going to be talking today, though, focuses on our work with Columbia County Habitat for Humanity and their ability to build affordable housing for the families in this area. This area lies just north of New York City, about an hour and a half to 2 hours drive. As you can see, it's quite rural, but it is also quite poor in the sense that many people live here are suffering from housing poverty. That's because the price of land is so expensive. It translates to the cost of housing is quite high. Families here can spend easily 50%, 60% of their income, monthly income, on housing. And the definition of housing poverty is if your family is spending more than 1/3 of their monthly income on housing. Housing poverty thwarts a community's resilience against economic downturns, natural disasters, and pandemics, as we're all facing now. The cost of living in Columbia County is extremely high. We have our workforce families often are spending more than 50% of their income on housing, and then housing in that regard is taxes, insurance, monthly maintenance, utilities. All of those things add up to the housing costs. We have good jobs here in Columbia County. Our rural workforce has jobs in agriculture, construction, education, healthcare, hospitality, and the retail sector. But good jobs don't help when we get hit with one very severe winter with the high utility bill. When that happens, and it happens, that families get forced out of their homes, and they will be moving from here to other areas that are have less severe climate and more stable utility bills. It may seem like there are affordable housing options around here, but even a mobile home rental is not going to lift someone out of housing poverty because their income will end up still, even at a very, very low monthly rent for the mobile home, being more than 50%, 60% of their income. The goal for Habitat Humanity is to provide them with not just housing, but a home that they can own. And a home that they can own that would lift them out of housing poverty. So their goal is, and they set their prices accordingly, so that they can sell new homes to families for less than 1/3 of a monthly expense than their monthly income. And this shows you how they determine the monthly payments that they have their families spend on their homes. And then that works out to be 1/3. The problem is that that assumes that a stable utility bill, and that is not the case around here. We can be hit with a very hard winter and suddenly their calculations fall apart. So Habitat for Humanity was asking us if we could take our experience with Passive House, where we've demonstrated that we can not only stabilize energy costs, but actually reduce energy costs to hardly anything per month. And if they could take that technology and apply it to the homes that they built. And they felt if they could do that, that would be the piece that would make their habitat families more resilient. And that's why we call this the rural build, because our intention is to use this technology to make a more viable, more sustainable rural workforce in our rural community. So how does Passive House make rural communities more resilient? This is the thing that we want to talk about today. But before we go there, we need to back up a little. We need to back up to the very first structure built in the Hudson Valley to meet Passive House standards. And it's a project we designed that ultimately became known as the Hudson Passive Project. It was designed originally in 2007 and then redesigned in 2008 once we were more familiar with Passive House techniques. This became a community effort because we applied to receive a high performance building grant from New York State Energy and Research and Development Authority. And with that grant money, we could tap into the resources of our other consultants, such as the great resources of the Levy Partnership, Inc. in building science team in New York City, terrific structural engineers, and then the best builders to help us. Why we were so intrigued about pursuing Passive House at the time, because we knew little about it at the time, was because Passive House, being so driven by metrics and being able to provide such hard data about what the energy actually would be used once you completed the design. Prior to that, we were relying on now it seems like old-fashioned techniques, passive solar techniques. And at the time, we created this case study to achieve what we determined would be LEED Platinum certification. A simple, small home, maybe 1,400 square feet, A-frame in style, using all the techniques that we knew at the time to conserve energy, passive solar techniques. We had that design completely built on paper, and we were ready to go to build. And then there was an economic downturn, the Great Recession. And we thought, oh, this is a terrific opportunity. Maybe we can create a case study where we had a home completely designed for one way of conserving energy and see if we can minimally change it to test these new ideas in Passive House that were new to us and unfamiliar to us. So it was a value engineering exercise where the value was to see if we could minimally change the specifications to save real ways to save energy with the metrics involved. And what appealed to NYSERDA was that we could have this apples to apples comparison because we had already completed this design for what was considered state-of-the-art passive solar approaches to what was unknown even to them about Passive House design. And we with the help of the Levy Partnership, we could run the metrics about what really difference it made to increase the thermal barrier performance, to enhance the ventilation where it could recover energy, and to minimize the heating and cooling loads. The results were astounding to us, not just to us, but also to everybody who participated. I mean, of course, we expected to save a lot of energy, but we had no idea of how energy inefficient the original design was by comparison to what we could achieve with Passive House. And I have to say that this particular home, its shape maybe being so almost like a sphere and compact, and because of these particular builders, we saved so much energy, it was hard to believe. 99% less energy for heating, 99% less energy for heating than passive solar, 86% less energy for cooling. And then we got to actually build it and run it for a year, and it proved to be just that. I mean, there was practically no energy used to heat and cool this house, even in our climate, even in a most severe winter. Right from the start, the Hudson Passive Project was a community build. It was the Great Depression. We had people hungry for something to focus on that was forward thinking. And in the Columbia County, we have a lot of builders. There's a lot of carpenters up here, a lot of local builders. It isn't that home building is done by large developers that come in. It's not like that here. And so we decided to turn it into a community event. And we talked to the community as we went along. We held presentations of what passive house techniques were. You know, we explained what we hope to achieve out of it. And we invited them to help participate in the creation of this new technology that was promising to save so much energy. And what we wanted to demonstrate very clearly is that we were using the same design that we had designed before, based on all of those things that we felt that people in Columbia County wanted to achieve in a home. And in no way we were designing a home that was somehow compromised or changed to reduce this energy. I mean, we designed this home before we even tried to make it passive house standards. So that same architecture being re-engineered for this new technology, and hey, look at the results. In that audience, and at these frame raisings and all these events that we had, were actually Habitat for Humanity volunteers. I mean, those builders would frequently volunteer for Habitat for Humanity builds. And this is where the idea came that could we take that technology and apply it to a Habitat project in the same way, in the sense that we wouldn't change what they would normally build. We would look at what they normally build and just re-engineer it. So not trying to create a new architecture, but taking what they know they can afford to build and what they know that their families like to live in and can afford to live in, and just change the specifications with the goal of making their utility bills more stable and ideally lower. Because, you know, as we said, when those utility bills go up even slightly, they are, even in a passive house that is a Habitat for Humanity house, even priced to be exactly what they could afford, when those utility bills go up, they're back into housing poverty. And that is not the goal of Habitat for Humanity. It's certainly not the goal for a sustainable rural workforce. We need to fix as well as minimize those energy bills. So because we had created this as a community build to begin with, and because there were so many Habitat for Humanity volunteers already participating, as I said, helping with the framing and learning as they go, we asked that same coalition of consultants that that were pulled together to receive that NYSERDA grant, if we would all be willing to donate our services to take that same approach to what they build. So we understood that even if we donated our services, that it would cost them more money to go from Energy Star 3 standards, what they would normally build, to Passive House. We cautioned them about that because at the lower end, there is much more of a price increase than at the upper end. But they were not concerned because A, we were donating our services, B, they already had a trained workforce, but C, their donors were more inspired to give more with the idea that the families would be in a better place and be more stable. I mean, everybody needs a stable rural workforce in a rural community. So it did prove to be more expensive. I mean, certainly there's more cost in the framing and insulation and thermal and airtight materials, but it's a habitat project. So there really is no increase in labor costs because labor, like our consulting services, is all donated. So here is a really interesting approach to helping communities get their families into more sustainable homes, focusing on what the community can do as community builds. And Habitat for Humanity is just one example of how communities can build for their families, and maybe a good way, and good entryway for how Passive House consultants can start to help lower income families in these rural areas. So as I said, we're taking the same approach where we take the same architecture and minimally change the specifications. In this case, the architecture reflects the architecture of what they typically build here in Columbia County for rural workforce families. It is homes that can work inside the villages in the area and on small lots. This is the type of homes that was just completed. It was an Energy Star 3 home. It was just completed the year that they asked us if we could take on this challenge with them. And so, as you can see, we were very, very true to our mission, as true as we can imagine to be, which is everything they were used to building, mimic the same volume, the same layout, ratio of the same windows. And we learned as we went that we could be even closer to exactly what they were used to building as we went along, minimally modifying what they built so that it could meet Passive House standards. We were relying on what we knew worked, about reducing the energy costs so that we could convince their board and their volunteers that this would be a worthwhile mission. Gave them quick examples of how we could achieve this within their current design. And as I said, they were somewhat familiar with they were very familiar with the technology, but actually showing them, how it would fit into their homes and giving them the confidence that it would be a minimal change. Of course, the key is that we were going to heat and cool this entire home, this entire Passive House design with just one mini split, a 3-bedroom, 2-bath house. We had to do the whole thing with just one mini split because that is going to be the only way that we could make it affordable. We had to minimize the heating, ventilating, and air conditioning costs because we were increasing the cost of other things. So it worked. We moved families into the Passive House. We managed to cut their heating and use by 90%, cooling use significantly, not as much as we wanted to in the first time around, because we overglazed actually during the first time around. We didn't quite understand the best way to move air around the first time around, working with just one mini split. but we definitely reduced their energy costs and we made them much more stable energy bills. So as we go forward, we were thinking, let's just try a little bit, change things a little bit more so that the homes are now even more comfortable to live in. So I want to give you an example of, a clear example of what these homes or how these homes are laid out. These are 1,250 square feet of usable space. There's a first floor, which is kind of an open floor plan. To the back is a flex space that could be converted into a ground floor bedroom if needed. We have the bulk of our mechanical system tucked into the first floor bathroom, but the rest of it is fairly much an open plan. On the second floor, we have a middle space that acts as a kind of transition space, if you would, from first floor and second floor, with an overlook into the lower level and a staircase. And then to the back is one bedroom, a shared bathroom for the entire floor, and toward the front is a master bath and another smaller bedroom. So this is our standard model. This is what they were building before, and we just duplicated it. One of the advantages that we had working with this Habitat for Humanity is they were already used to building twin homes, kind of mother-daughter homes, 2 units side by side. Why that's a huge advantage for Passive House is because it increases the exterior surface to the interior volume area by moving 2 families into one structure, a bit more squarish. We managed to make it even more squarish as we went along. And that way it's still tiny houses, but not so tiny that the ratio for the exterior surface to the interior surface made it harder for us to achieve the desired heating and cooling loads with the equipment that we had to use. I want to emphasize the shift that this has for a family that was renting in a mobile home beforehand. Again, it may seem affordable that you spend $1,100 a month, but when you get rent and then you add it to your utility bill that goes from, you know, $300 some months, $200 other months, maybe $375 another month. Now you're talking about $1,475 a month, which for one family, one particular family, meant that the home, the woman who was the single mom had to hold down 6 different jobs just to make ends meet on any particular winter month. So you move that home, that family, into a Habitat home. Of course, they can set their prices to their family's income, but then you reduce their utility bills to nothing, practically $83 a month, and stabilize that at $83 a month. The change in their lifestyle is dramatic. That family who the mother had to hold 6 jobs suddenly could afford to keep her family you know, making ends meet with just 1 job. And you can imagine that. I mean, if you get hit with an energy bill that is $200 a month more than you were expecting, I mean, that's a trip to the dentist. That's a pair of, that's tires. That's all those other essentials that you need to keep yourself working and to keep yourself out of poverty. That is what I think we often forget, is we think that energy is cheap, but it's not cheap. It's not cheap to our hardworking families. Oh, thank you. Thank you so much for allowing me to pre-record it and to share that with you all.
Wow, Dennis, I got some questions queued up for you, but just on a couple of things, if you want to just take a second, I just want to point out that just because I saw Mary James in the crowd tonight, so her amazing efforts in getting the Passive House Accelerator magazine out came out today. You probably saw an email in your inbox about that. And if you want to hear more about from Dennis, he is on the podcast episode 23, and I've just put those 2 links in the chat so you can you know, download and check out those later. For those that don't know how to save the chat, In the chat, there's 3 little dots just by the file. You can click on that. You can save the chat and get all these links later on after you've, walked the dog or had dinner, or, wake up tomorrow, or again, for those that are enjoying the happy hour from overseas, and it's Thursday, you might want to check it out on your lunch break. Okay, Dennis, hopefully you're ready for the onslaught of questions. Here we go, starting
Hey,
off
Sean.
with, oh,
can I interject real fast? And
sure.
I know we're all eager to dive into questions after this amazing presentation. I just want to remind people to put your question in chat, and Sean will field those. And we're also always eager to hear from new voices. So yeah, if you're new to the community, Sean's likely going to raise your question up to the top. Feel free to ask any and all questions here of Dennis as we proceed. Thanks.
Excellent. Thanks, Zach. So Chris said that he's not able to chat. So his question, he had a couple of them, but I'll pull up his first one. Are these units movable? Thinking of climate refugees and on that regard. So
no, these are site-built homes. They are not modular. And that's a very interesting thing, because we considered a lot of options. Every time we build a case study, we test different methods of construction. And so we did consider prefabrication at one point to create these units. But as it turns out, when you have the benefit of volunteer labor, the most cost-effective approach is to bring bring materials as raw as possible to the site, because then you're leveraging all your volunteer labor. So rather than spend money in prefabrication, which is where you have to spend, where Habitat would have to pay for their labor, we opted out of. We actually took away more and more prefabricated components as we went along, so that so they became more and more site built, and that saved more money as we went along.
Great stuff. Okay, heading over to Tom Phillips.
Oh yeah, hi. Yeah, that's a great way to help people survive in their housing, and I'm sure it's going to get worse with climate change. So I was wondering about things like climate readiness and adaptation, and increased solar gain from windows and so on. And you addressed some of the overheating, it sounds like, but did you consider also external shading or overhangs or anything? I saw you had some maybe on the lower floor.
Right, we only had overheating with the very first home, because when we did the thermal modeling, we anticipated that we would need, we would need more sun to keep the interior warm. That is one thing that I want to caution people about thermal modeling. Sometimes, well, in my area in particular, there's a lot of microclimates. So it's really impossible for thermal modeling sometimes to accurately predict the heat gain that you're going to need. So as it turns out, we once we returned the window size to what was a more traditional kind of double hung window size here, we never had any problem keeping things warm, and reducing that amount of glazing helped to keep things cool. The other thing is that the overheating was also caused because we couldn't figure out with the mini split where to put it and how to keep the air moving around, relying only on the ERV to do that. And we learned that by moving the mini split upstairs, and so originally we had it downstairs, and then creating this overlook, which I think yeah, exactly. We created a loop. So cooling is also, it's also a visceral thing. I mean, in our area, people will open a window and rather be a little bit warmer with open windows, as long as there is a breeze. So that was another important thing to actually kind of tap back into some more passive solar memories, and to make sure that we got cross ventilation in these units. And so people, so with regard to adaptability, one thing I think is again really important about community builds is you're taking the brain trust of a community, and you're getting to test, you know, how things are working, learn from the prior families. Actually, we even have prior families help build the next one. So you build in something of a science that goes beyond what you can necessarily find in books, if you would. It turns it back to the more traditional way of learning when you build.
A quick follow-up question about software for Passive House. Which version of Passive House did you use? Does it make a big difference in terms of heat thermal assessments?
No, it didn't. I mean, we continually changed too as we went along, because now, I mean, we started the first one and designing the first one in 2010. To tell you the truth, we wouldn't even need to run the calcs now. I mean, we are working with an area that is, you know, by town, it's not that unique. And also we're in the villages of these towns. So, you know, the whole idea of you know, what is the soil type and what's the distances between the buildings, it's all kind of close. And we probably wouldn't even need to do the calculations. I mean, that is how site specific and how community specific we are right now. So
great, thanks.
So everybody, just getting the questions queued up. There's a bunch just came in, but we're gonna head over to Jeff.
Oh. Hi, fantastic. I think that the Habitat for Humanity's model is really interesting. My question got to the location of the single mini split, and I think you sort of answered it, but what were the considerations around air movement to sort of keep the different regions of the residents the same temperature or different temperatures? Sometimes people want to, you know, sleep in cooler rooms and that kind of thing. So how did you deal with that? And then the other question I have, which I didn't put in the queue, sorry, Sean, was more about the consistency of your project team and the builders and subcontractors who you work with, and how consistent that was.
Great questions. Yeah. Well, for the first one, again, we learned from prior homes and from what the experience that prior families had, you know. So first thing that we did is we moved the mini split upstairs, because originally we thought we would have more trouble heating than cooling. And so we wanted to then locate the mini split where it would be needed most for cooling, which is for sleeping. But at the same time, you know, cold air drops. So we created that overlook that allows the cold air to blow out and at the same time part of it drop. And then if it's not dropping quick enough for that lower level, there's a ceiling fan in that intermediate space. So they can turn the ceiling fan and push the cold air down. So they can close the bedroom doors during the day, have that cold air come out, and by that ceiling fan, it pushes it down both from the overlook and from the staircase. As far as, you know, what, you know, make one bedroom cooler or warmer than another. I mean, this is a family house, you know, kids, teenagers are always hot, you know, so they have to leave the doors open, you know, is that so bad? You know, it's like, you know, and you're also talking about people that are coming from, you know, the worst possible substandard housing, and they understand that, you know, that there is a certain amount of care that has to be given and consideration given they're not like luxury homeowners that are expecting too much, you know, in the transition to the next luxury apartment. And so that's a huge advantage. And to emphasize that, some of these volunteers spend more time helping to build the house because the house is warmer even before it's finished than the home they're living in. So it is quite a remarkable change in their lifestyle. As far as the building team, one of the mission statements for our local Habitat for Humanity, which aligns so perfectly with the Rural Builds mission, is that they want to also train builders. So we try never to repeat the building teams. We always try to find a whole new team to come in, and then, you know, we get volunteers that are consistent, that, you know, like, you know, non-builder volunteers that are consistent. So they're actually learning from the amateur builders, the new contractors that come in. The new professional builders rely on the amateur builders to show them, you know, what they did in the last house. And, you know, that also allows us to learn, you know, better ways of doing things, because every time a new builder comes in, they always try to beat the last guy, you know, and make it go quicker and make it go better. And so they add their brain trust to it. Again, the emphasis is that as an entryway into a community build is really a good one. I'm not saying Habitat for Humanity is the only option. I mean, there's, you know, a lot of limitations for Habitat for Humanity. You have to be a first-time home buyer, you know, and you have to fit within this very, very narrow window of what income levels that you can be in. So if we as a passive house community could start to work with church organizations, other kind of community build efforts to tap into what we're able to achieve with Habitat for Humanity, I think that would be a great way to start introducing passive house to the lower income families.
Sean, can I have one more follow-up question?
I'm going to just pause you just because we're a bit tight for time. So hold on, Jeff, we'll hold it for the after hour. Just because we need to head over to Zach. But Dennis, hopefully you saw the chat and all the praise you're getting, and just the whole concept of including the community. It's been great. So Zach, over to you.
Fantastic. Thank you, Sean. And thanks, Dennis. This is amazing, as I knew it would be. So evenings like tonight are made possible only through the support of our sponsors. So I want to give them all a big thank you and encourage you all to include them in your projects as you move forward in passive house and high performance building. Our founding sponsors are 475 High Performance Building Supply, Baxtingui Architects, Glavel Foam Glass Gravel, Minotaur, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are BR+A Consulting Engineers, Brennan Installation and Airtightness, Inotech Windows and Doors, and US Engineered Wood, T-Stud.
Thank you so much, Dennis. You're very inspiring, and you're taking concrete action where many of us are wondering, how do we get involved? So you're giving us very, very real life examples of how to do that. So thank you really a lot.
Thank you.
So for those of you that need to go be with your families and have dinner, thank you so much for joining us. We hope to see you again next week, or next Tuesday and next Wednesday. And for those of you who can stay, we'll roll into more Q&A with Dennis. Thanks, everyone.